Have I started streaming right now? Uh, this is the internet speed, which is around 100 Mbps. Okay, I'm using 4% of the CPU just for streaming. I don't know how well I'm audible. Let's go here and go to live section and see whether I'm live or not. Okay, I'm live then. Then you have to edit things here right now so that um, anyone can view it. How to do this? How to change the privacy from unlisted to listed in YouTube live stream? How to change the privacy from unlisted to listed live. Uh, from the menu on the left, okay, however the video you want to update and click on the live stream. Okay, so actually I can go to the live stream right now. What I can do is simply, I don't know how to do this thing. Stream settings. I think these are the technical specs no one needs to hear about. These are the technical specs of the stream. Uh, we don't care much about it. I think we should need to tweak this privacy stuff. Where can I do that? Hmm. Stream is healthy, fine. Where can I do this thing? Ah, timestamps, reactions. I go to studio. Is my stream going on? That is going on. Like even if I do something, the stream goes on. I go to content, I go to live, and here I guess here I can do this. What you see now I can do the public here. I guess I guess we are live right now. Now this is done in public. I need to have the URL so that uh, I can get to share it with someone. Let's learn CUDA. Let's not learn CUDA. Uh, let's implement uh, from scratch type things. Let's learn CUDA only. We have the NVIDIA compiler. Let's learn CUDA. The stream needs to be very focused. It is only about learning CUDA and nothing else. So 11th February 2025. This is my first public live stream. I need to get a shareable link for this. How do I get a shareable link? This is the link. Okay. This is shareable link. I can see whether I'm live or not. How will see that? I'll switch to incognito tab. I'll make the window small. I'll go here and I'll pay it out. I guess that's how we do it. Okay, so we are live. That's nice. I guess I can see the status always here. We are live from for the last 4 minutes and 15 seconds. I go to the terminal, close it up. Now let's begin learning CUDA. Hmm. It will be fun. This is my first ever public live stream. Let's learn CUDA. I'm not seeing the chats at all. Later I'll think of how to integrate it into my OBS so that I can just use the OBS stuff for live stream and just focus on the work and don't do anything else. That would be fine, I guess. So what we do? CUDA tutorial. That's how we start. Uh, let's not learn CUDA like this. We'll start with Claude and start with a system prompt. Hey, you are my CUDA learning assistant. You will guide me throughout the process. I have uh, decided to learn CUDA. Let's begin with this system prompt. I have all this compiler and all installed. Hmm, I guess I have this folder called CUDA. It's not there. I guess it's on inside code. Yes, CUDA. Yes, it's there. I can open it this folder in the VS Code. Yeah. So yeah, we have our first CUDA thing. I don't know why I'm not getting the search bar here. Everyone is getting that. I'm not getting. This is the compiled executable of the CUDA file, and this is the file where I've written the CUDA code. I have written something before. I don't know exactly what this does. But let's begin from scratch. Um, let's begin from scratch with the name of the file t.co test.cuda. Let it be like this t.cu. This is the file extension of the CUDA program. Actually, it is an extension of the C++ as far as I know, but we can always check this out. We go to the terminal and we have the CUDA compiler, NVCC version. See, we have the CUDA 12.2 R12.2 compiler. So this is the exact version, but it is CUDA 12.2 roughly. So that is the major thing, and all these are sort of minor thing about it. So we have the CUDA compiler, we have the C++ compiler also, as you can see, and we have this is actually C compiler, this is C++ compiler, which is G++. Okay, fine. We have everything ready. Now we can start writing a CUDA program. Let's begin. I'll be happy to help you learn CUDA. We'll have a 2 hour session, like it's 10:45. Uh, I think we'll go for like 11:45 and 12:45. We'll go till 12:45. Uh, till 1 a.m. Okay. Mhm. Okay. I am fairly comfortable with C++. Uh, make me learn by doing giving me simple snippets and trying to modify it or make some changes to it, thereby getting a hold of underlying concepts. So it started generating something. I think the first thing it got generated is a lot of things. I don't know this much. I guess we can get started with this. Start with the right import and then we can go on. Okay, I want to know, is CUDA a layer on top of C or C++? Let's ask this to Gemini. Is CUDA layer on top of C or CPP. Hmm. CUDA is not exactly this, it's hard. Okay, let's think how to declare a variable first. Like what are the imports in a dot CUDA file? Basic imports and basic imports. Okay. I think this is the library I had imported here. CUDA runtime. I think this is the one responsible for everything. Let's go through this code I wrote few months back. Like you have a CUDA kernel here, which is nothing but a function. You have the host code, the code that will run in CPU. Okay. Then setting the kernel parameters and launching it. So this is the kernel you write and you are pass it the parameters. Now what are the parameters? The second kernel parameter denoted how many cores will run a single given thread. Okay, so 200 cores will run my single given thread. Uh, okay, what's the first parameter? What are the parameters in a CUDA kernel? Kernel is a function. Mostly, what are the parameters for while uh, launching CUDA? This is the operator, which is triple angle brackets, as you can see here. This parameter CPU. Okay, so grid and block. Acha, like inside grid, there are many blocks. Each block will contain 10, 24 threads. I mean, what this thing is basically how many threads you are running in each block and how many such blocks you are running. So blocks constitute grid. Let me tell. Let me uh, confirm whether I understood understand it right. Grid um, uh, block dim is basically number of threads running and in a single block and grid dim is basically how many such blocks are there, which means total number of threads running is uh, grid dim times times block dim. I guess. Okay, so represent the number of threads within a given single block. Think of a block as a block div क्या represent करता है? Number of threads represent करता है. Okay, block div contains number of threads. A bunch of threads is called the block dimension. So what will be the block dimension? The number of threads running inside the block. What will be the grid dimension? Number of blocks constituting that grid. So total number of threads is this. Okay. Can we have a way to verify this? We can have actually. Uh, okay. We'll start writing this code. Let's start to get a hang of the. So we got these two things: grid dimension and block dimension. I guess. This is a grid dimension. That means we have only one grid. The grid dimension is one. That means we have only one block, and each block runs 200 such threads, which means 200 parallel executions of my function is happening. Which means if I call the hello CUDA kernel with these two kernel parameters, I will print hello CUDA 200 times. That's what it means. Okay. We have imported this uh, include CUDA underscore runtime. Okay, so that's the idea. Hmm. Let's get a hang of this CUDA thing. We have the host code and we have the definition of the CUDA kernel. That is the device code. Can I call CUDA kernel as device code? Can I call CUDA kernel as device code and the main function in a CUDA program host code? Acha, CUDA kernel is indeed considered device code. So, okay, what are the basic template of writing? What is the basic template of writing a CUDA kernel? Okay, so this global keyword. What this does? Okay, we'll talk about this later. I guess let's do a simple quick check to understand things. So what is the first thing we import is this library, CUDA underscore runtime. Now we have the host code, which is the main function. I guess it takes the parameter. Hmm. Let's see. It also returns something, an integer, and we have a function. Let's say hello CUDA, and I launch it with some parameter. I don't do any data transfer. I just simply run this printf command parallelly in 100 threads. Let's think of it like this. Now, co- how define a CUDA kernel? Uh, so you have this global keyword. You attach as a prefix is the return type. Like you prefix before the return type of the function. So return type of the function is So when you write a simple kernel, like sample test kernel, let's say a test kernel. So you have the return type function which is void, and let's say I call it test function. This is my function. and it takes no parameter, and it returns nothing. It's void return type. It simply prints something. Print that. The C out work here will see hi. So this is what I started to print. I have to use a semicolon. C family of languages. I have to use a semicolon. Why it is like this? Why printf is not working? Okay, I've not imported this thing. Standard input output library, and I think it should be imported. Okay, I guess I have. Okay, this is my function. This is the entire function. Now, how? Okay, let's not attach the double underscore global keyword before the return type of this kernel and try to run it out. How we run it? Um, like now start the running of the function. Start execution. Okay, we simply call this one. Make it simple. Let's say we call this function test fun. How it last time. Um, I call this like this. Now the grid dimension is one. That means there is one block inside the grid. And how many threads are inside each block? There is single thread. So how many threads are there in total? There is one thread in total. That means my high should get printed only one time, which is similar to the normal thing without this CUDA and stuff. How I call it? I call it like this, I guess. Now I guess you can run it out. How you execute this actually? Okay, so it's same thing how you execute it. I guess we have to get it out. Okay, it's actually MVCC version. So I have this file t.cu. It's MVCC file name. The executable file I wanted to compile it to T. What it says: a host function call cannot be configured. You are calling this function as a host function using this thing. If I delete it up and run it, it will run fine. It will run fine. You see, it is running fine. It is not printing anything, but it is running fine. But if I execute this, it can't be executed in a C compiler, I guess. No, it cannot be executed. And if I execute this in CUDA compiler, I don't like nothing gets printed. Not even this one. Not even this one. Which is really amazing. Why this is not getting printed. Mhm. Device launch parameters. Is this essential? I don't know why you have imported it. Okay. Let's do the standard practice. Let's attach this global keyword. So you have this and you run like this. Okay, what the fuck I'm doing? I'm not executing the file. Lol. I should compile it and then I should execute it. T.co, compile it to T. I guess we have compiled, then we need to execute T, start execution. The execution starts, but nothing gets printed. Why? No high gets printed if you see. Is the autosave on? I guess it's on. But no high gets printed. Why the why the high doesn't get printed? Dot slash T not execution and insert a new line. I guess it is always compiling the new one. Right? Okay. Compiled, let's execute it. Yeah. So what is the issue here? I want to know. Let's say I print that and I do something. I what I do is I execute in a single line, compile and execute at the same time. It doesn't print. Something is missing. What is missing? Let me ask GPT. So inside a kernel function, I am just printing uh, a string. But when I launch that kernel from the main function and execute the file, nothing gets gets printed, and I want to know why. Acha doesn't work as expected. You cannot print something directly from CUDA kernel. Why? The process is being executed in the GPU, and I don't think I think to display something in standard output, you need something in like GPU, like some process. I don't know. Let's see. Actually, it's a separate device. Standard output functions are typically associated with the CPU environment. Okay. GPU doesn't have direct access to the host output stream. Yeah, I think I guessed it right. Mhm. Okay, like I guess I think we can't do some quick testing. We have to get into this complex stuff of copying stuff in and out of the GPU. You have to figure that thing out. I thought I can just print stuff in parallel and see. I don't know. Let's copy this code and give to Claude. It is more complex. Let's start try something simple first. It is very complex as of now. Let's try something simple first. I wrote this simple program which doesn't show any output when executed. Acha. The reason you are not seeing high output is because CUDA kernels are asynchronous. They return immediately while the GPU continues execution. Acha. So you have something called CUDA device synchronize. So that sync it like okay, got it. When one thread completes the execution, the return happens immediately. Okay. to wait for the GPU to finish. I also modified the print thread is printing. Acha, you can get something called thread IDX. कहाँ से लाओगे? Where did thread IDX come from? Okay, I think this thing. CUDA device synchronize, that's why it was added here. CUDA device synchronize. Not added here. Makes past kernel launch synchronous. I need to understand this function, what it is actually doing. CUDA device synchronize, we'll look into that later. For now, let's write it and see. CUDA device. So it's in what case you call that? Oh, you said like camel case. American English synchronize. And you return 0. So for now, let's make it like little bit clean. Let's try to execute it. Yeah, I see. Yeah, nice. So we can clearly see 10 threads are getting executed. It makes all the threads synchronous. What happens because of it? No idea. We'll check into that. Are we streaming right now? I guess we are. We are streaming from the last 31 minutes, which is great actually. Ah, okay. Nice, nice, nice. Okay. So right now I have two rabbit holes. I can get into what this function is doing, and I have this CUDA device reset function. Yeah, this is also in camel case. So it's CUDA device reset. I have this function also. I don't know what. I have to understand the movement of data from CPU to GPU, like from the host device, from the what you call that host device to what this device is called. Yeah, from the host to device. We have to understand how the data moves from host to device. Okay. How the data moves from host to device. Okay, got it. I to understand this asynchronous behavior. What exactly is asynchronous? What exactly is asynchronous as behavior in programming? Acha. So it's like 10 threads are running. Uh, so every when each thread ends its operation, it returns something. Why you need to synchronize them? Why you need to synchronize so that? Can you have a Gemini session on it? What exactly this CUDA device synchronize function does is not good. I need to open new URL. What exactly CUDA device synchronize synchronize does I guess this is spelling is it uh, that blocks the calling host thread until all previously requested tasks on the device have completed. This includes kernel launches, asynchronous memory copies. What this means? Mm, okay. Maybe I don't know whether I understand it right or wrong. So when you call this function, there is a main thread in the host which calls this GPU kernel. Now, what this function does is it doesn't allow the main thread to get like to return unless all the threads that has branched out from the host thread has executed completely, has been executed completely. So for this is the main thread in host, and this calls this GPU kernel. Now, till all of the threads the main thread instantiates does not end and returns to the host, it will not allow the host thread to, to return. So it blocks the host thread from getting executed. Uh, so does that mean this function? Let's verify what we understood is correct. Does this mean the function basically blocks the main thread until the threads running in device uh, completely executes and return to the device. No, returns. Yes. Essentially blocks the calling host thread until all previously launched tasks on the CUDA device have completed. जब तक जो टास्क कोडा में चल रहा है वो कंप्लीट ना हो तब तक ये मेन थ्रेड को ब्लॉक करके रखता है. So what the memory copies also happen automatically, I guess. So we write what this does. It blocks memory to the threads. So this is one block. This is one block. Okay. So the grid dimension is 2. That means my each grid has 2 blocks. This is the grid dimension. How many blocks are there? And in every block, how many threads are there? So that is the block div. So every block runs 3 threads. So like 20 processes are running in parallel. 20 threads. Now I saw something very interesting. I have this thread ID stop X, and I also have something else. Let's explore this. What this is. I have 3 4 things. Thread ID dot Y, and there is thread ID dot Z. Now, what these things are? It's, I guess one must be the okay. Let me predict what it is. X is the thread number. Like inside a given block, what is the index of the thread? So, like in like my kernel parameters are like I have 10 threads in each block, and I have two of such threads. So dot x thread thread index x dot x is like the index of the thread inside a block, and thread ID xy is like which block, like there are two blocks, and this is which grid. That's the idea, I guess. Like that's why there are 3 numbers. I can add something else also, which I have not mentioned right. I hope that is the thing. Hmm. Hmm. I guess yeah, that's it. Right. I don't know whether it is correct or not. What does thread index and thread ID dot x, thread ID dot y, thread ID dot z represent? Whereas whereas I just know that I just know that thread like ID dot x represent the uh, index of the thread in a given group. Mhm. Acha, CUDA organizes threads in a 3D structure within each block. Think of it like a 3D, 3-dimensional grid where x is the width, y is the height, and g is the depth. Height and width and depth. Just think of it like a block. So I can pass this thing dim3. So thread is a 3D, like how it's synchronized. Mhm. You can execute like this. That. Like even if I write like 200,000 and now this will print 1 million threads, but will be